Hi guys, this is O-level chemistry, paper 12, November 2021, question 1. In a titration, 25.0 cm cube of aqueous sodium hydroxide is transferred into a conical flask. A few drops of indicator are added. Dilute hydrochloric acid is then added to the flask until the end point is reached. Which piece of apparatus are used to measure volume in this experiment? Okay, to measure dilute hydrochloric acid, we have got a burette and a pipette as an option. And to measure aqueous sodium hydroxide, we've got beaker, pipette as the options. Okay, so now first thing, we are carrying out a titration in which 25.0 cm cube of aqueous sodium hydroxide is transferred into a conical flask. So in a titration, all the volumes that are taken are supposed to be accurate volumes. So in order to measure accurate volume, the apparatus that we are going to use are burette and pipette and not a beaker. A beaker can be used to contain the liquids, but it cannot be used to measure the volume because we need accurate volumes. So first thing first, beaker is eliminated. So options A and D are not correct. So now we have burette for HCl or burette for sodium hydroxide. So now again, in a titration 25 cm cube, they have fixed the volume of sodium hydroxide that we are going to use. In order to take accurate fixed volume of a solution, we have pipette as the apparatus because 25 cm cube pipettes do exist. So sodium hydroxide will be measured using a pipette, which is there in both the options B and C. So now we have to decide what to use to measure the volume of hydrochloric acid. Now, we don't know what the concentration of sodium hydroxide or hydrochloric acid is. So the volume that we require for HCl will have to be obtained through titration. That means we need an apparatus that measures variable volumes but accurately. And the only apparatus to do that is a burette. So the correct answer for measuring dilute HCl would be a burette and not a pipette. So this makes option B the correct option for this question. Question 2. A student follows the rate of the reaction between marble chips, calcium carbonate, and dilute hydrochloric acid. Equation is given. Which diagram shows apparatus that with a stopwatch is suitable for this experiment? So rate of reaction is being followed, which means we need to have the gas that is produced collected and the time to collect the gas measured. So the first experimental setup has a measuring inverted measuring cylinder placed in a trough containing water with a delivery tube going into it. That means we are collecting the CO2 gas over water. So this piece of apparatus can be used to measure the rate of production of carbon dioxide gas. So setup 1 is correct. Now the second experimental setup, we have a weighing balance over which we have placed a conical flask with a plug in it and marble chips and HCl. So this will allow loss of CO2 to occur because CO2 will pass through that cotton wool plug, and this would result in a decrease in the mass of the container. So loss in the mass due to loss of CO2 can be measured using this apparatus. So this apparatus is suitable. Now let's look at apparatus 3. We have a conical flask with marble chips in it and we have got a burette with HCl in it. If we open the tap and let HCl flow into the container, it will react with the marble chips and CO2 will be lost. So this apparatus is not useful in following the rate of reaction. So experimental setup 3 is not required. So since we only require experiments 1 and 2, this makes option B the correct option for this question. Question 3. Pure oxygen is needed by many industries. How is pure oxygen obtained in large amounts for such uses? A. By decomposition of calcium carbonate. Calcium carbonate is CaCO3. When it decomposes, it produces calcium oxide and carbon dioxide. Oxygen is not a product of this reaction. B. By decomposition of hydrogen peroxide. Hydrogen peroxide is H2O2 and when it decomposes, it produces H2O and O2 as the products. But this is not how oxygen is used for industrial use. By filtration of liquid air. If we are filtering the liquid air, we are removing impurities and dust from it. So this does not include production of oxygen gas or separation of oxygen gas. And D, by fractional distillation of liquid air, yes, this can specifically be used to separate oxygen in the liquid form, which can be used for many of the industrial processes. So this makes option D the correct option for this question. Question 4. An impure sample of compound X has a melting point of 120 degrees Celsius. X is purified and its melting point is measured again. Which row is correct? Okay, first of all, we need to remember that melting point of an impure substance will be lower than that of a pure substance. That means when X is purified, its melting point would be greater than 120 degrees Celsius. So first thing, we have two choices, 115 which is lower than 120 and 125 which is higher than 120. So it cannot go lower, it will increase if the substance is purified. So options C and D may be the correct option, A and B are not. Now, the two processes involved in purification are crystallization and distillation. Distillation separates liquids and crystallization separates a solid when dissolved in a solution. Now X is purified and its melting point is measured again. So purification would include crystallization. So if crystallization is the option here, then option C is the correct option for this question. Question 5. An aqueous sodium hydroxide is added to aqueous compound X. A red-brown precipitate is formed. When dilute nitric acid followed by aqueous barium nitrate is added to aqueous compound X, a white precipitate is formed. What is X? First of all, we have a red-brown precipitate forming. This indicates the presence of Fe3 positive ion. Now, in the next step, we have nitric acid followed by barium nitrate. So a compound, when added to compound X, a white precipitate form. When barium ions are added, they react with sulfate and they react with sulfide. So this could be sulfate and sulfide, but we are sure that this is not sulfide and this is sulfate because nitric acid has been added. When you add nitric acid to barium sulfate, the precipitate remains, while if you add nitric acid to barium sulfide, the precipitate would have dissolved. And in this case, because nitric acid was added before the addition of barium nitrate, the precipitate would not have been formed in the first place. So since the precipitate has been formed, that means our compound X contains Fe3 positive ions along with sulfate ions. So option A, chromium sulfate, sulfate is there, chromium is not. B, chromium chloride. Chromium isn't there, chloride isn't there. C, iron 3 chloride. Iron is there, chloride isn't there. D, iron sulfate. Iron is there, sulfate is there. So this makes option D the correct option for this question. Question 6. An aqueous solution of zinc chloride is tested by adding reagents. Which observation is correct? Okay. Acidified aqueous barium nitrate is added, forms a white precipitate. This would only happen if sulfate was present. So option A is incorrect. B, aqueous ammonia is added, forms a white precipitate soluble in excess of the reagent. This is what happens to Zn2 positive ions in solution. When ammonia is added, a white precipitate of zinc hydroxide would form, and when it is added in excess, this would dissolve to give a colorless solution. So option B here is correct. Option C, aqueous sodium hydroxide forms a white precipitate insoluble in excess of the reagent. Forms of white precipitate is correct, but in sodium hydroxide also it is soluble in excess, zinc ions. So the observation is incorrect here. And option D, powdered copper, forms a gray precipitate. nothing will happen when you add copper to zinc chloride because copper is less reactive than zinc, so it will not replace zinc in the salt solution. So this makes option B the correct option for this question. Question 7. A sample of gas is released at a particular point in a lab. A detecting device is placed 10 meters from the point where the gas is released. This device detects and records the time when the concentration of the gas is 10 molecules in every million molecules of air. Okay. The experiment is carried out with two gases at different temperatures. In which experiment was the time recorded by the detector greatest? Okay, so we need to find out under what conditions which gas would diffuse slower than the other. So, rate of diffusion depends on temperature. The greater the temperature, the higher the rate of diffusion. We need to have a lower rate of diffusion, which means out of the two given temperatures, 20 and 40, temperature of 20 is correct and 40 is incorrect. Now, we have two gases, SF6 and CO2. Now, the rate of diffusion would depend on their MR. The greater the MR, the slower the movement, the higher the MR, the faster the movement. So, between SF6 and CO2, the MR of SF6 is greater than CO2. We don't even need to calculate it here because sulfur has an AR of 32. Oxygen has an AR of 16, so 16 to the 32. We add 12 for carbon, getting 44. And we have got 6 fluorine atoms present. So the mass would be greater than 12 for fluorine because the mass of one fluorine is 9, if you remember. If you don't, it's there in the periodic table. And still, if you don't refer to the periodic table, look at the number of molecules in SF6. This is much greater than CO2. So MR of SF6 would be greater than CO2, making SF6 the gas that would diffuse the slowest at a lower temperature. And this makes option A the correct option for this question. Question 8. The table shows data of some particles. So we've got sodium ion, fluoride ion, and magnesium ion. Na positive, fluoride would be F negative, and magnesium would be Mg2 positive. We have the number of protons, the nucleon number, the proton number, the number of neutrons, and number of electrons. What are the values of W, X, and Y? Okay, so for the sodium ion, we need to find out the number of neutrons. The number of neutrons is the nucleon number minus the proton number. So W is given by 23 minus 11, which is 12. So options A and B have been eliminated. The correct options is either C or D. So now next, let's find out X. So X is the number of neutrons. The number of neutrons is equal to the number of electrons is equal to number of protons plus 1 because it has a negative charge. So a negative charge would mean that an additional electron is present. So 9, which is the number of protons, plus 1, which is because of the negative charge. So overall, 10 electrons are present in the fluoride ion. Again, both options C and D have 10 for the value of X, so we will have to find out Y now. So Y is equal to number of protons. Now, number of protons is equal to the proton number. So proton number is 12. So Y is 12 here. So out of the two options, C has the value of 12 for Y and D has the value of 10 for Y. So this makes C the correct option for this question. Question 9. A covalent compound P has the empirical formula of CH2O. Which structure represents P? Let's find out the formulas. So for A, we have there is one carbon, there are two hydrogen, and there are two oxygen. So A is incorrect. B, we have got two carbons, we have got four hydrogen, and we have got two oxygen. This can be further simplified into one carbon, two hydrogen, one oxygen. This is the correct option. C, we've got two carbon atoms, we've got four hydrogen atoms, and we've got one oxygen atom. This cannot be simplified further, so this is wrong. And for D, we've got three carbon atoms, we've got six hydrogen atoms, and we've got two oxygen atoms. Because there is an odd number of carbon atoms present, this cannot be further simplified, so that makes option D incorrect as well. So as a result, option B is the correct option for this question. Question 10. Which statement about the structure of bonding of metals is correct? A metal lattice consists of negative ions in a sea of electrons? No. It consists of positive ions in a sea of electrons. B. Electrons in a metal move randomly through the lattice? Yes, because they are delocalized. So electrons will move randomly. C. Metals are malleable because the ions present are mobile? No, because the layers of positive ions can slide over one another. So the reason here is incorrect. And D, the ions in a metal move when positive and negative electrodes are attached. No, they don't. Electrons in a metal move because they are delocalized. So option B here is the correct option for this question.